Hi, my name is Ingus and I'm owner and founder of a company called IGS Electronics, and today we are going to look into continue from the last video of wiring up this J1000 Yaskawa inverter drive, which is a single to three phase. We're going to see if we can get this controlled in a local mode. The bits we're going to need for this is this is going to be, by the way, this is going to be the first first way, the way we can control this drive. There's a couple more, I think it's one more way we're going to be trialing on a video, but there's a couple of more ways of doing it. Actually two more ways we're going to do it, and we'll see how they all work, and then how to do the wiring for it, and what parameters to change, how to set up the parameters. But today we're going to start the basic of the basic things you can do with this drive to get things going. So in here we have a little box that I could find around with the selector switch in here, and a small emergency switch. I'll explain to you in a minute what it does and then how it works. And then we have a potentiometer, which you are able to change the frequency to the motor. And what I got in here is like you can get these potentiometers literally anywhere. They sell them literally anywhere, and then I got this nice one from RS Components. I think I paid about £4 or £5 for it. It's a nice compact one, no soldering needed. You can directly wire into the drive or extend the cable wherever you wish to put that potentiometer, and what position you would like to do it, it doesn't matter. So that is that, and obviously we have our trusty motor down here, and obviously the drive. So pretty much the first thing what we're going to be doing is trying to control this in a very basic way, which is what they call a factory preset way. And as you can see, a little manual down here, this is pretty much the way we are going to work and run this drive. As you can see down here, regarding potentiometer, always pay attention to what manufacturer tells you to do, what sort of what size in kilo ohms the potentiometer needs to be. And as you can see very closely in here, it says it has to be 2 kilo ohms. So that's what I have here. So the first things first, to be able to run the drive in a remote control, you need to tell the drive that that's what you want to do, because at the moment the drive is set up in a local mode, and then if you flip like a switch now, nothing is happening. So no frequency is changing, just doing absolutely nothing. So first things what we need to do is change some parameters to make sure it knows what you want to do. So first things first, to be able to run the drive into a remote control, we need to change some parameters. So pretty much we have to tell the drive that I don't want you to any longer to run and accept commands from the front keypad. I want you to start accepting commands externally. So first thing what we need to do is change where we read our frequency, and to do that we need to, if you read the manual, it tells you what to do. So we need to go to B, parameters, enter, to the B section, enter, and 01 is parameter for frequency reference selection. So we need to enter that and change the frequency, and make sure, because for whatever reason Yaskawa put 2 zeros in it, which is very confusing. You move that onto the dial like that and press that up, and then press enter. And as we did that, if you escape, you should be able to see that your drive now reads the frequency 14 rather than 0 than the way it was. It's because now it accepts this little potentiometer, whatever it reads from that. So another thing when we can still keep it like that, and we are able to start the drive, and when we do that, it will start running the motor. As you can see, let me zoom it out. See, now it is running the motor, and from start stop is happening from the front keypad, but the frequency from now on is controlled from the potentiometer that we have right next to it, and what we wired it in already. So let me see if we can show you in a camera. So by turning that, now we control it from there. So the next thing, if you have connected something like buttons, what we can do, you need to make sure to if you want to change any parameters, you need to make sure that you are always in a stop mode, otherwise it will not let you do that. So to change where we accept commands from regarding starting and stopping, we need to change the parameter B0, B1, 0, 2. So down, enter, up, enter, enter, 1 up, enter. We need to again go across, put it up, enter, and as you can see, I'm not sure you can see it in the camera, the little light where it says local run is no longer available, but I think you can still select it independently by clicking on it. It goes back to the local mode. You're still able to run it from here, and when you click again, it goes to the remote, as it says near LO and RE, local for remote. So now that we have changed our parameters, let's see what it does. So now that we have changed the parameters, let's test what it is. According to this diagram, I will show you the wiring in a minute, how we got to this setup, how we wired it in a minute. So we're following these basic diagrams. You can see that's what it says, what it's going to do: reverse, forwards, external fault, and fault reset, and multi-speed. That's what we're not going to be using at this stage. That will be for the later videos to show you how you can effectively use multi-speeds if you want like specific frequencies to specific applications. You are able to select, I think it's about three or four different preset speeds, which you can just activate by flipping a switch. So what we have in here, we can go forwards by clicking that. Obviously my thing is around there is a bit different, so that goes reverse. Signal basically comes from the reverse cable, and you can change the speed with your potentiometer now. And as you can see, it's slow down. Let's just see the little bit of video now. Slow down, and then basically the acceleration. It's taking its time. So we can obviously change that by adjusting the acceleration times. Which, if you watched the last video, you know how to do that by now. It's for your specific needs. And at the same time, if you flip the switch, the drive will stop, and it goes the other way. So basically forward and reverse. That's what it does by basic factory preset settings. So now it's accepts this switch. So remember, this is non-latching. So every time you delatch the normally open contact, which you show you in a minute, and here it'll stop. So that's one way of stopping. And the reason I wired this little red switch in here, there's a little contact in here, which the manual says is classed as external fault, which you can send directly to the drive. In the case, I wouldn't class this as emergency circuit, because for the emergency circuit you mechanically need to disconnect power from motor, which we will be covering one day in other videos. But for today's purposes, we're going to say that there's something down the line that in case you think it happens, you want that to be sensed in some way by a sensor or switch or whatever to send the drive signal. I would use that as a very only in a critical situations to activate, to stop the drive and activate, and say there is a fault. So if I click that button now, it stops instantly the motor. And so if there is a load, obviously it's not going to stop that instantly because it's I'm not using a brake, but it has gone into alarm. So now that when we activate some sort of fault or whatever fault you want the drive to receive in the case of an emergency or some sort of a specific alarm that you want to stop the drive, specific sensor or whatever you're connected to, or in a car amps it could be a high level sensor or on a laser, something in some sort of whatever. It's just that there's options. It's for specific equipments, so you can have this optional system, or not system, it's just the wiring. You can take that directly to the drive and put the drive into alarm and instantly stop the equipment working. So to basically to reset it, if you see, if I remove the alarm, and as you can see the switch down here is still in run, but it's no longer doing anything and it's still flashing on the screen. Now that you removed the switch, the what they call the activation signal, the run has stopped, but the alarm still not resetting, because basically what it does is asking you to confirm that you have acknowledged the alarm, and it wants you to actually accept it by, if you look at the manual, it says the fault reset. As we have not connected the fault reset button to it, we can reset it by on the drive alone, and by clicking that, and it resets it and it returns back to its normal condition, provided that you have cleared the fault and the sensor is no longer active. But if the sensor still is in it, and you or sensor or switch, whatever you're using, you won't be able to reset it until you have rectified the problem that you have by yourself set it up to be. And as that will be cleared, it will allow you to reset. So that what I would call a sort of a basic ways of running. And now we're going to look into the thing what they call in a manual. Again, do read your trusty manual. It gives you a lot of guides, what they call the 3-wire sequence wiring. So we are going to wire this up in a minute, and I'll show you how that works and why that sometimes is good and sometimes is bad. But to generally explain this system, what we're going here, this emergency switch should not be used as your primary safe isolation. So basically, not self isolation, basically cut off from the motor. That should be only used specifically if you want something to go directly to the drive to stop. But for emergency circuits, which when you build the system, you should have a way of activating an emergency switch and completely disconnecting power from the motor, unless you're using different systems that would activate DC brakes and stop motors instantly. But again, we're covering these things a bit more later on in later videos, which there's a lot to cover in these systems. But if you go looking for the basic way of doing it and some sort of what we call safety and a quick way of stopping it, and because you're obviously not always going to jump, if you're using the select switch to start the system, you ain't going to be having any quickly want to stop something. By the time you get to it, you're trying to switch it off and maybe flip to the other side, and whatever way you connect it, and it might cause a damage or whatever is happening down there. The best way probably would be, again, not advised as a safety system, but to say if you are going for the very basic, at least install something like that and send the fault to the drive to instantly stop the motor. So that would be my advice, how if you're running without a proper way of doing it. And now we are going to look into another control system, which is called a 3-wire sequence, which is controlled a little bit different, and probably your original DOL starters, or whatever the starters you have, would be able to operate this drive that way. So let me get to it, wire up and show you how it works. But forgot one thing before we get to it, to the next wiring sequence. I'm going to show you how we wire this one. So let me just take off the cover and pull this one through. So what we got in here, if you look at the on this bigger wiring diagram, and it shows you that if you want to activate any of these functions, which you've seen in the other page down there, all you need to do is send 24 volt signal from the drive into one of these points that are assigned already by the manufacturer, and which in our case says S1 would say go drive forward, and S2 would say drive go reverse. And you can see, if we look at a bit closer to the, see if we can get as close as we can with a decent zoom. As you can see down there is a little block with a sign that it says SC. So all you do is run the cable, because this is basically your source to activate any of those inputs, which are S1, S2 and S3 in our case, that what we are using. You basically, as I can't show you too, you run up, oh, let me just zoom this out a bit, oh, the other way. You run that SC signal in the, show it on there, in I have run into this side of the contact blocks and basically gave it to all of them. So from this goes from there to there to there. So basically all these receive this source signal from source wire from the drive. So any of these contactors will close. They will send the signal, again you run the wires back from here all the way to where you want each of these things to activate. You run them to the inputs assigned according to manual. It's quite straightforward. You get your source, you run to your contact, and then you give the source to everything you want to run, and then send those signals back to the drive and activate whatever you're activating and whatever you want to, and however you want to run, or whatever you have assigned to those specific inputs. Because for many drives, you can, it's like later on we cover the Siemens, you can actually assign what those inputs do. And this one, this is all preset. You just stick to the preset setting and you'll be just fine, nothing to worry about. And the little potentiometer is literally quite straightforward. Follow the manual, because we're using the voltage 0 to 10 volts. And if you can see my little dip switch right here, ooh, way back. As you can see the dip switch up there, I and V, you need to make sure that that is always if you're using the current, it's in I mode, and if you're using the volts, it's in the V mode. So, but if you look at a little wiring for potentiometer, it's literally 3 wires, and in my case, in my potentiometer, it shows a black, yellow and red what it do. I usually, quite a lot often these will come with no wiring diagrams on them at all. This is the basic potentiometer, and then obviously they all will work and things like that. Don't worry about it. Just follow the little rules that the potentiometer. I don't have that page here with what this manual tells you. So VA1 and AC must be used for the voltage potentiometer. So all you need to do is put 3 wires. If you don't know which one is which, just put 3 wires in all those 3 designated points. If you don't know where it goes, and quite often you won't, and it will not harm the drive in any way. It will just perform not the way you want it, or it's gonna be like you going up and it's gonna go down, and then it's gonna just swap it. Just keep swapping until you get it right. If you don't know, and literally no way or other way of finding out how to do it, the potentiometer says it's not gonna harm the drive. You can swap things around until you get things working in assigned inputs, which the manual tells you. Don't go anywhere else, to make sure that you follow the manual and its diagrams, which ones are meant for potentiometer. So that's the wiring part of it. It's quite straightforward. Literally use your source, send it to the switches, and from switches you send the source back to whatever you want to activate in this case. Like in S1 we say go forwards, in S2 we say go backwards, in S3 you say activate drive fault or external fault, so stop the drive. So it's quite straightforward. Hopefully that makes a lot of sense. So let's get to the next wiring diagram, which is a 3-wire sequence, and see how that works. So just did the full rewiring, and just realized that the video is running quite a long, and we have still quite big things to cover. So I will end this video here, and we will continue with the 3-wire sequence and multi-speed wiring into the next video. Hope this video was somewhat helpful, and you found it useful, and thank you for watching, and I'll see you in the next video.